So I want to welcome everybody to the Ethereum Community Staking Call number 5. This call is generally titled Ethereum 2 Wallet Management. Our special guest today is Jim McDonald. I met Jim through Reddit when he posted, or someone posted Attestant.io as a blog, and my immediate response was, I don't know who this guy is. We shouldn't trust him. And I was swiftly corrected and realized shortly after that Jim is the master of the ETH2 key manager, wallet manager that I'm fond of. And he is behind Attestant. Tonight, we're going to talk mostly about Ethereum 2 wallets and wherever else he wants to go. Before we get too far into that introduction, let me tell you hello. My name is Super Fizz. You can call me Fizz or whatever you want to call me. I do have a real name somewhere. My co-host for tonight, as always, is Lamboshi, who is slowly growing to be Nolan, his official name. And Patricio Werthalter is with us tonight, representing POAP. Patricio, do you want to tell us a little bit about POAP before we start?
Yes, my pleasure. So POAP gives every attendee a non-fungible token on the Ethereum mainnet, or ideally gives a token, because right now the gas is so expensive, so the minting fees are complicating our operations. But the idea is that you get these tokens that only you own, and you can use to claim that you are part of this community early on. And in the future, you may get access to some different opportunities, given that you are a person that is committed to the community. There were POAP on previous talks, and hopefully there's going to be POAPs of the upcoming ones. So make sure you get them. The way they are delivered is that you get a private message on the Zoom chat from Lamboshi, and you have to make sure that you click the link or you open it before the call finishes, because once the call is finished, the chat goes poof, so you don't get the token any longer. If something doesn't work the way it should work, or you want to learn more, feel free to reach out to me personally, or get into POAP XYZ on Twitter or Telegram or anywhere else. I think that's it, and please enjoy the call and enjoy the privilege of having such a master as an honored speaker today.
All right, thank you so much, Patricio. And before we go to the next step, I want to say this community is where we identify ourselves as the Ethereum 2 Staking Community. We generally are based at reddit.com/r/EthStaker, but that is more of a conversation platform for us than our entire identity. Like I said, our intention is to, as much as we can, represent all of the Ethereum staking community. Lamboshi, do you have anything you want to say before we hop in here?
No, I don't think so. Let's get underway. I'm excited for this one.
All right, me too. So I'm going to spotlight Jim. And I've given his introduction. So Jim, if you'll just pick it up, I think you know the big scheme of things. We want to know, what is wallet management like and key management like in Ethereum 2?
Cool, thank you very much. So yeah, I would say the best description is nascent. We're not there yet by any stretch. There's been an awful lot of work done over the past few years on building Ethereum 2 nodes, looking at the beacon nodes, the validators and similar. Keys have very much been a means to an end until now. So most of the nodes out there will allow you to generate keys. They will be written to disk in various forms, and some of those forms are old. So for example, some use the old Ethereum 1 key store. Some of them are just simple unencrypted dumps of private keys. So there's a range of things out there. There has been work done to try to provide standards for these, and that's something that is ongoing, and that's great to see. But one of the things that we don't have or haven't had historically has been a way of having those keys separate from the nodes themselves. Now, we want to have keys separate from nodes for various reasons. So one of them is it allows us to move keys from one type of node to another. You want to move from Prism to Lighthouse, then you can do that. If you want to move from Lighthouse to Deku, you can do that. So that's certainly one of the reasons why we're looking at more and more key management pieces. The other one is that the operational security of your keys are actually very, very different from what you would expect on an Ethereum 1 system. So in Ethereum 2, validators have two keys. One is called the Validator Key, the other with the Withdrawal Key. Ideally, a withdrawal key should not touch, possibly never touch, a machine that is connected to the internet. So your withdrawal key is very much the thing that you want to keep safe. Most systems at the moment, the nodes will create both validator and withdrawal keys next to each other. So because of that causes a situation where immediately we're not into the best operational security. Now, of course, we do expect this to change before the nodes go live. We expect to see a lot more of this kind of level of security coming in. But what we need to do is make sure there are options available now as early as possible to be able to keep the withdrawal key secret, to be able to ensure that people can start to get the hang of the operational security that they are going to need when Ethereum 2 goes live.
You are mute, Superfees.
Well, sorry. In our pre-meet, we talked about some of the new features of Ethereum 2 wallets that we're getting used to Ethereum 1 wallets now after 5 years. Can you talk to us about some of the features of Ethereum 2 keys and wallets that we just may not even be aware of at all?
Sure. So one of the biggest things that's difficult for people to wrap their heads around when they start looking at Ethereum 2 and specifically the validators is this idea that there are two separate keys for a single validator. So there is what is called a validator key and a withdrawal key. The withdrawal key owns the 32 Ether deposit. It retains a 32 Ether deposit. Any money that is earned as a result of validating goes into that same account and always controlled by that withdrawal key. So the withdrawal key holds the funds. The validator key uses the funds to attest to proposed blocks, a few other bits and pieces. So there's a nice separation between the operational side, what you are doing on a day-to-day basis, where you need your validator key to be available, to be online, and what you want to ultimately be able to do, which is withdraw your funds and use them for other purposes, which is something that the withdrawal key will do. So as we say, these are very, very different keys with very, very different uses. However, that's never really made explicitly clear. Again, a lot of the nodes, when you create a new key, you create a validator key, it automatically creates a withdrawal key without telling you and adds it in. So you don't even know half the time what's going on. So the idea between having a validator key and a withdrawal key is something that is very new, and that's something that's very important. That feeds into how those keys should be created, how they should be stored. There's a whole bunch of things around that in terms of who actually owns and uses those keys. So because they're two separate keys, you can get into realms such as non-custodial staking, where one user holds funds, the other one holds the validator key. So there's a whole bunch of things there you can do. It's a relatively flexible system, but again, it's one that doesn't come without complexity, and it's very important that people start to understand the difference between the two keys, how they should work, where they should reside, how you should look after them.
So the biggest difference from the outside is that there are two different keys. Are the wallet addresses still the same 64 string length, or is that different? Are the private, do they look different on the outset than Ethereum 1 keys?
So with Ethereum 1, what people generally think of as keys is actually addresses. So the 40-digit address that you'll see, which is normally a hex string, it is normally a mix of upper and lower case numerical alphabetic characters along with the 0 to 9, is an address. So that is actually a truncated hash of a public key, which immediately is painful to think about. Ethereum 2 uses something similar to Ethereum 1 in terms of how it creates keys and uses keys. It has a separate curve, which, without getting into the details, is a different way of generating a private key, generating a public key from a private key. It uses that for various things under the hood, but one of the things that Ethereum 2 does not have yet is addresses. So when we think of an Ethereum 1 address, which is that 40-character string, we don't have the equivalent in Ethereum 2 purely because we don't have user transactions yet. So we have no need to create an address. When we do, there is most likely to be a much more friendly format. We have learned quite painfully over the past 4 or 5 years that not having checksums in addresses as a primary method of the format has caused people to lose funds. They mistype a character, they miss a character off the end and it assumes there was a 0 in the front. Those type of things that happen can cause big pain. So at this moment in time, we do not have an address format, but we will have by the time that they become useful. In the meantime, the Ethereum 2 keys, public keys, are actually a lot longer in Ethereum 2 than in Ethereum 1, so they're significantly larger in that respect. But they look similar in that fundamentally they're all big numbers which are normally represented by hex addresses. It is something that we need to get the hang of, and this is something actually we've talked a little about wallets and wallet management. The standards are starting to have, for example, names automatically attached to wallets, automatically attached to addresses. This becomes very, very useful because now when we want to talk about an account, we can say, I want to exit validators /17. That is an awful lot easier than looking at lots of different hex strings, trying to ensure you have the right one and similar. So again, as these standards start to come through for Ethereum 2, we are learning from a lot of the, not necessarily mistakes, but the early decisions that we didn't make to allow that user friendliness to come in. So certainly we are seeing public keys of a significant size. They are not mapped to addresses yet, but hopefully that will become less and less important as we start using more friendly names and similar.
Are they still going to start with OX?
So all of the hex strings will start with OX. So when we look at public keys and private keys, we're going to see OX. When you look at the current idea of where we may go for Ethereum 2 addresses, one of the ideas is to take one of the standards that actually came out of Bitcoin, something called ETH2, which is a relatively nice format. It includes a prefix. So we can have a prefix for the mainnet. We could have separate prefixes if we wanted for test nets that were up and running. So there's immediately something that we didn't have in Ethereum. Then we can move to the fact that it has lots of good checksums in. So actually the chance of mistyping either by missing characters or transposing characters, the chance of the checksum validating is very, very low. So we are likely to see something that has those properties if it is not exactly what the Bitcoin guys are already doing with ETH2. So it's going to be something of that ilk, but certainly user friendliness. Not in terms of length, unfortunately, there's a limit to what we can do there because it has to store a certain amount of data. But in terms of being able to clearly see what network we are using the address on, ensuring that we don't slip up when we mistype, those things are something that I think are going to be pretty important and high on the list when we start to look at an actual address format for Ethereum 2.
So I kind of presume that anyone who is interested in wallets for Ethereum 2 right now, since transactions won't be possible for what looks like a year, they're only or primarily interested in staking. And so from the perspective of securing funds as a staker, since we don't have any assumption when hardware wallets might be available, how would you guide us as far as best practices for securing it's a lot of ETH for a lot of people, for securing our keys as we enter staking?
So there are a couple of things there. I mean, something you mentioned, which is very important to know, is that yes, as of today, there are no hardware wallets that support the Ethereum 2 keys. So unfortunately, that takes us back again, sort of 6-7 years in time, to when we have to look at other ways of keeping keys secure. As we mentioned, there are two separate keys: withdrawal keys and validator keys. If you were looking at a high security system, you would probably look at a single server that was fully offline. What that offline server would do would be to actually generate both withdrawal keys and validator keys. So that would be an offline server that would then generate both withdrawal and validator keys. The reason why you want them both on the offline server is because it allows you to easily create the deposit data, which is the information you input on the Ethereum 1 chain to create an Ethereum 2 deposit. So you have an offline server where you have your withdrawal keys, you have your validator keys, you can create deposit data. What you can then do is, using a USB stick or similar, you can take the validator key and the deposit data, and you can put them onto live networks. So deposit data, as we mentioned, will go on an Ethereum 1 transaction. The validator key you will put on one of the beacon nodes and the validators there. So your Prisms, your Lighthouses, your Takus, Nimbuses, etc. So what you then have is a situation where you have your validator key active on a server. Now, that is obviously a concern. If we assume for the moment, and let's do that, because if we assume we take our withdrawal key and we lock it in a safe or whatever it might be, let's assume that one's safe and that one's secure. We can use crypto steals for that. We can create a hierarchical deterministic wallet, and we can just store the seed for that to create them. That's all safe. Protection of a validator key is a much more difficult problem. The reason for that is simple, is that every 6 minutes, a validator key must be available and online to sign something. Always an attestation. In addition to that, potentially a block proposal. There are a couple of other things under the hood where, again, signatures are required using these keys. So because of that, even if we got to the stage where we had, say, Ledger decided that tomorrow they can support the Ethereum 2 curve, it wouldn't really work, because you'd have to be sitting in front of your Trezor device every 6 minutes to say, yes, I approve this transaction. Yes, I approve this transaction. So a lot of the things that we are used to in terms of key security, unfortunately, don't quite work for us. The main and the obvious thing that we can start to do is protect the server on which that key resides. So ensuring that our server is secure, that it is not running a whole chunk of other services on there, making sure we have a firewall in place. All of your traditional operational security is very, very important. The problem then remains that you have a single key, or a key on a single server, which is vulnerable. If that server is hacked, the key will be stolen. If you have someone decide they want to denial of service your machine, then you can no longer carry on because that key is in one place. So because of that, as we spend more time looking at the world of validators, we realize that there are various things that we need to start doing to ensure that, without decreasing the usability of the system, we can increase the security of the key. And that there's a number of initiatives we can chat about there, but there's a lot going on there to try and see how we can keep this combination of having the key available and ready to sign things, whilst at the same time avoiding the issue of making the key too easy to steal, and as a result, users potentially having their funds lost.
Okay, one of the things I want to probe at, you said the best key generation standard was an offline server. Now, that could be something as simple as Raspberry Pi that's running keygen software, right? Like it doesn't have to, there's no need for horsepower. It could be a simple appliance that's air gapped to generate those keys, right?
Absolutely. You know, the power requirements are very, very low. There is BLS code out there for most of the architectures that we know of, so it's pretty easy to run this on anything. You can get computers that sit on USB sticks. Yes, you mentioned the Raspberry Pi, an old laptop. You know, there's lots and lots of options out there. The important thing with that is just that you make sure that once you start using it, that you keep the whole thing air gapped, so those withdrawal keys will not make their way onto any kind of net connected machine.
And so, in the absence of a hardware wallet, I'm assuming, at least I know I'll be using an HD generated wallet, and because I'm a weirdo, I'll probably do rolling dice and flipping quarters to create my HD wallet, and then brute force the checksum, which I assume is at least as far as I know is a secure way to generate it. In terms of using, so we've got the validator key and the withdrawal key. Are people assuming, are they going to have two different HD seeds? Is that how that would work?
So personally, I would recommend it. The reason being that, again, if you want to have some way of accessing your validators, let's say the server on which your validators was running catches fire and you need to recreate those keys, if you then have to put in a seed that could also recreate your withdrawal keys, that is going to be less secure than just having a separate seed for the validators. So keeping those two things separate in every way possible is, in general, good security practice.
Am I correct to assume that HD wallets are probably the most logical route for our level of end users? Is that?
Yeah, I mean, again, it depends. With an HD wallet, they're very, very useful for validators. If you're creating multiple validators, certainly that's great because you have a single seed and then you can create multiple validators. You do not need to have separate withdrawal keys for each validator. They can all be the same withdrawal key. So if you end up in an environment where you have a withdrawal wallet seed and a single account, maybe you want to think about doing something different in terms of how you create that. Certainly, as we say, you know, an HD wallet has lots of advantages. If you want to create multiple withdrawal accounts, then that's great. If you just want one, then maybe there are other options. The other thing with individual keys, again, is that at some stage you might be thinking, well, actually I want to find some higher level of security than what I have at the moment, and there are ways to do that. For example, the traditional one is Shimmy secret sharing, where you can take a single key, you can break it into multiple pieces, and then you have what's called an M of N system. For example, you might put the key in 3 different places. You need 2 of those different pieces to be able to recreate the key. So that type of thing starts to become interesting as well. A lot of that then comes down to functionality. So if you do Shimmy secret sharing on a seed, that's fine, but you lose a chunk of your functionality in that you can't create new keys or similar or whatever without having those pieces.
Shamir's secret sharing scheme, that would be an offline solution for storage, right? That wouldn't be a computational solution. I mean, I know it's generated computationally, but my use of that has always been like, here, give it to my buddies physically.
Yes.
Or is it's not a computational solution?
No. And again, that is the type of thing you do, as you said, before you move the key away and forget about it. But as we know with Ethereum 2, phase 0 is not going to allow us to carry out transfers. Phase 1 kind of maybe might. Let's not worry too much about the details yet. People are still kicking it around. So we might be able to have transfers in phase 1, but they are at least a year away, if not longer. So certainly being able to protect those keys, the withdrawal keys in some sensible fashion of burying it in a box and forgetting about it is probably the single safest way of doing that. You want to do that with a HD seed, or you want to do that with the private key itself. It's much of a muchness.
Okay. So I love that you've given us so much practical guidance, because this is uncharted territory, and it's so much to consume for any of us. Like, we hold these conference calls just because it's, as end users, like it's overwhelming. And so it's great that you have so much of background in this. And Patricio asked a great question, and something I haven't thought about. What gets you where you are? Like, what background have you had that has allowed you to be so knowledgeable about this cryptography?
Well, I mean, my background itself goes back quite a long way now, about 30 years or so. I started working with computers. I did a computer science degree at Edinburgh University back in the 90s. And a lot of my time there was actually spent not doing computer science degrees, but working on a public access system that they were running. So we were running I think the second public access system on the planet in terms of computer systems. And it was a great grounding. And from that, it was really a whole bunch of different jobs, both through technical, through management. I've worked in small and large companies, et cetera, et cetera. The background for me has always been, I want to know how a technology works if we're going to use it. So if I'm selling something, if I'm building something, if I'm using something, I want to sort of dig in and see how it works. And I mean, that led me a long time ago to Bitcoin. I rewrote bits of a Bitcoin Explorer back in 2013, I think it was, or something like that. But then after that, it really was a case of keeping an eye on the technology and seeing what it was doing. So in terms of understanding, generally speaking, I will pick a project, I will start to dig into it, I will start to raise PRs against it, I will sort of smooth out some of the rough edges and similar. So you start with a lot of the less functional stuff, but really find your way around a code base and work from there. Ethereum 2 in itself has been interesting because it's mutated quite quickly. So what Ethereum 2 looked like a year and a half ago is not particularly similar to what Ethereum 2 looks like now. As such, it is becoming less of, but is still a little bit of a moving target. And the best thing to do is just to get involved. Find an area where you have some past experience or some knowledge, help out, get involved, and you'll just start to soak it up. And that's probably the single best way of getting involved in any project, is just to pitch in and help out wherever you can. That allows you to understand what's going on. It allows you to be able to start to sort of see the shape of these projects. For me, I mean, if I go back to Ethereum, I actually started on a side project working on state channels, and I went from state channels to a whole bunch of other little areas and pieces inside Ethereum where there were the bits that weren't doing what they should, or they just weren't working the way that I wanted them to. So you kind of pitch in and you start to play around with stuff, and if people like your work, they accept it. If not, they don't. That's fine. But you learn. So certainly cryptography and Ethereum and cryptocurrencies in general feel like they are massively technical undertakings, and a chunk of it is certainly having a bit of ability with maths help. Being able to understand crypto helps up to a point, but you don't really need to understand that to know what's going on inside Ethereum. If you look at Ethereum 2 and proof of stake, an awful amount of it is game theory. It's understanding, how do you stop people from being bad actors? How do you ensure that the right people are rewarded and the wrong people are punished? How do we make sure that regardless of who wants to watch the world burn, we can keep this chain running? So, a lot of that is, that's not coding, that's thought, that's playing around with game systems and similar. So there's a whole bunch of areas there that are very, very interesting. And as we've sort of talked about before, blockchains are wonderful technical endeavors, but they're also wonderful social and economic endeavors too. So there's a huge problem space out there for people to tackle in their own areas of interest and their own experience and similar. So yeah, you know, there's a huge amount out there to get involved in all areas.
Yeah, so I think most people who know about your contributions, at least at my level, I can't speak for anyone else's experience, but we see the Attestant.io blog. And so do you want to tell us a little bit about what Attestant is and how it fits into this whole picture and where it's headed?
Sure, and Attestant is a good example of something that came out of the problem statement, which is that it would be absolutely great if we could have a system that could stake for us. So Attestant, and you mentioned the blog, and a lot of those was, let's see if we can understand this to the depth where we can explain this clearly and simply to anyone who's passing by. So that was important for us to be able to do that. Once we've done that, and once we spent more and more time in it, and again, you know, it's a lovely idea that the thing will be fully decentralized. We, the founders of Attestant, are all big fans of decentralization. But the reality is that being able to actually have to look after servers 24/7 is a significant task. Now, yes, servers can go offline if they're staking, that's okay. But how long can they really go offline for? How long are you prepared to let them go offline for? What are your costs to sit there and keep your server up to date, to keep reading about all the latest updates for all the various nodes, to run 3 or 4 different nodes to test them, and then test them again 3 months later, and then test them again 3 months later? So there was a lot of work involved in staking. Now, that's fine. You know, there is always going to be a barrier to entry for these things. There are requirements to have these things working. So Attestant initially was a project that we built internally to say, well, we would like to stake our own Ether in a system that is far friendlier for us, far easier for us to use as a group of 6 of us all that hold Ether. How can we build a system that would actually mean that we're not all spending a significant amount of time looking at chasing down bugs, fixing issues, ensuring uptime, ensuring security, et cetera, et cetera. So the idea for Attestant really came from that question of, well, can we build something that is a good staking service? Now, what we didn't want to do, though, was go down the road of saying, well, what actually we'd like to do here is take everyone's Ether, because again, being Ether holders ourselves, one of the things we said is, well, we don't really like this idea of giving up control. Fortunately, as we've mentioned with Ethereum 2, we have these 2 separate keys, a Withdrawal Key and the Validator Key. So one of the things we looked at very early on was a question of, well, can we separate these 2 keys? Can the Ether holder retain the Withdrawal Key without having any impact on the validator's ability to stake? And the answer is yes, you can. So that's a feature that we find is absolutely fantastic. We're very happy with the idea that what we can do is we can turn around and say, okay, great, we are non-custodial. You can keep your key, no problems at all. We're happy with that. We'll run the validator. You control the funds. Everyone's happy. So that was a big piece of where that came. And one of the things, and of course it ties back to key management, one of the things that we have as an ongoing question is, how do we keep funds safe? Now, most people have gone out there and read through and you know, looked up on bits of Ethereum 2, and one of the big things they crash into relatively early on is this idea of slashing. So slashing is a massive concern. We expect that we will see slashing from a couple of major areas. One would be malicious users hacking. So someone hacks, steals your key, has a bit of a laugh with it by burning all of your funds. Well, that's very nice of them, but hey. So that's not a good thing. So we want to avoid that if we can. The other one is just software bugs. We've seen various software bugs in protocol so far. So either inside the protocol itself or inside the implementation by individual clients, and we don't expect them to go away. More importantly, we also expect that although we found a bunch of these and a bunch of people have been kind enough to point out issues and errors, once there is real money involved, we expect that to step up significantly, both in terms of the attacks that are going onto the network and the ability for people who have probably already found attacks to keep them, and then they're going to start playing with them as soon as real money hits. So there's that concern of how do we stop slashing, which is a huge area. So one of the things that the Attestant have been working on is what we call a remote signer. So the idea of a remote signer is that you can take your keys and you move them away from the validator. You put them on a remote signing box. Putting on a remote signer is very useful for a few reasons. One is that if it's a dedicated box, you have a much smaller footprint for attack. So realistically, you will have one port open. That port will be purely for taking signing requests, so you can protect it a lot more than you could if it was a generic box that's running, say, an Ethereum 2 node, maybe some metrics on it, you know, sending information out to ETH2, ETH2 stats, excuse me. So there's a whole bunch of things there that you can do that you have to worry a little bit about less when you've got a dedicated signing box. Second thing you can do is you can start to put slashing protection in place. So what you do is, rather than just sign anything you're given, you put a whole bunch of constraints around it. So they can be technical constraints around, for example, okay, if we did this, we know we signed something 5 minutes ago. If we sign both of these things, someone could use that to cause a slashing attack, so we're not going to do it. We can restrict which IP addresses and servers and all that kind of stuff can actually access the signing. So you start to build in a system where you have stronger and stronger protections. The other reason why a remote sign is very interesting is because, although, as we said earlier, there are no systems out there today in terms of hardware keys that support the Ethereum 2 curve, there will be. And when there are, that means that we can actually have a remote signer that uses the hardware key rather than software keys as we have at the moment, which will of course give us another layer of protection as well. So as we start to do this, we find ourselves with stronger and stronger protections. And these are the type of things that we are going to have to build in for stakers big and small. It's you know, someone might have 1,000 validators, great. Someone might have one validator. Doesn't make any difference. You know, the impact to them of being slashed or being offline is very similar in terms of percentage loss. So we want to make sure that these features and functions are available for everyone. As we mentioned, you know, this is all going to be open source stuff. There is some open source code out there already, and it keeps being added to. So certainly that's something that we believe very strongly, that the more this is used, the safer staking on Ethereum 2 becomes, the higher participation we get, the more secure the network is.
Okay. You said something that had not crossed my mind before. I know Nolan and I both, Lamboshi, also we're using a 2-server setup, and my initial design was that they would switch back and forth between validating, but you raised the suggestion of the architecture being the primary server running ETH2, and then behind that the signing server. Is that that's kind of new to me. It seems like a really great idea. I don't know, can you just elaborate, because I liked it. I hadn't thought of it.
Yeah, so excuse me. So yeah, it gives us a lot of ability. So one of the things it allows us to do is run active servers. So if we look at Attestant servers for the moment, the ones that are running on the Topaz network, we have 2 beacon nodes, 2 validators. The validators all have the same keys on them. But the validators both talk to the same remote signer. What that means is when the validators come to attest, for example, they will race each other. They will go and talk to the remote signer. The remote signer will sign the first one that gets in. It will refuse the second one. So that allows us to bring servers up and down relatively easily and painlessly. So that, yeah, that type of thing is very, very useful. You know, we also, one of our problems, of course, with something like this is you never know if the thing is actually working or not. So a week and a half ago now, I actually turned off the slashing protection piece to see how it worked. Interestingly, it actually ran for a couple of days before we had a bunch of slashings. But the nice thing is we did get a bunch of slashing, so we can see that it was working. I've now turned it back on, I think. So we're now back in a world where we're being protected against slashing. So that kind of thing is really, really useful. Unfortunately, having built this architecture, what we next find, of course, as always, we're just moving weak points around, we now have a single signer. So we mentioned earlier the idea we didn't want a single point of failure. So one of the things that we have with a single signer is a single point of failure. So the next step is to find a way of distributing the signer. So we are now into a world of things that are under development rather than publicly available. Certainly we expect it to be publicly available pretty soon being in the next month or two. But what we're doing at the moment is looking at having multiple backend signers. So we mentioned Shimmy secret sharing earlier, the idea that you could break a key into 3 pieces and have 2 of them available for signing, any 2 of them. So we're looking at something similar to that, but a little bit more advanced. So Shimmy secret sharing is great in that it allows us to take a known secret, break it into multiple pieces. So we could have 3 separate backend signers, and any 2 of them would be enough to create a valid signature. That's great. That's wonderful. Our problem with that is that it requires us to know the secret to begin with. Now, as stands at the moment, you may think, well, don't understand what the problem is. Nothing wrong with that, right? You know, at the moment, I know a validator secret key. I'm going to end up still knowing a validator secret key. There's been nothing lost. So certainly if we go that route, then we end up in a world where we have more resiliency. As we said, we can lose one of the 3 signers and we can still carry on as normal. But again, we want a more decentralized world where possible. So one of the great things that the new Ethereum 2 curve gives us is something called distributed key generation. With distributed key generation, we can take those 3 remote signers, we can get them to talk to each other to create a validator public key. But it is a validator public key which no one knows the secret key of, no one. So the secret key is never actually created. What happens is the public key is an aggregate of individual components. The secret key, likewise. What we can actually then do is create a world where the 3 signers, each of them have a piece of that secret key. Any 2 of them, again, can create a valid signature, but at no point in time has that secret key ever actually been created and exposed. Now, this is really, really important, not for us today, for Attestant setting up 3 servers and running a signer across them, not for some guy with a server in his basement who decides he wants to run something in the cloud and have his signers safe there. But it allows us to do something where potentially anyone can run a signer, and when we create keys, then those users can choose the signers that they want to trust. And again, those signers can be hardware signers, they can be software signers. You might say, you know what, I'm going to trust Microsoft and Amazon and Google, and I'm going to run, there's a guy down the road I know who's running one. I'm going to have 5 in total, and I'm going to trust any 3 of them. Now, the nice thing with that is you can be pretty sure that Amazon, Google, and Microsoft, they're not really going to collaborate to steal your key. So by having the ability to set up antagonistic partners who each have an interest in serving you from their infrastructure, but have no interest in collaborating with the other people who are serving your keys, then you end up with a world of even higher security. So now we have a world in which secret key is never presented anywhere the people holding the fragments of the secret key are not going to cooperate with each other to expose it, but you still have the ability to, for you as the ultimate holder, to be able to ask them to create signatures. So it's a very, very strong system. Now, a lot of this is a fair way down the line, and there's a lot of work to be done. The technical piece is relatively well understood. The harder piece is creating the governance to do this, just simply saying, well, how do the servers all talk to each other? Convincing people they want to run these signers is another big area. So it's something that certainly long-term we want to do. But what we're trying to do, certainly as Attestant, but generally in the wider Ethereum 2 community, is try and keep moving ourselves towards that. So as we said, we have a remote signer. We'll be bringing out the split remote signer with distributed key generation over the next couple of months. The idea is to make these things available, and then hopefully over time, as best practice starts to come through, we will see more people become interested in doing that and providing higher and higher levels of security for validator keys. And it cannot be stated too strongly how important it is to protect those validator keys. We are in a bit of a weird world in that, as we said, traditionally you either have hot keys or cold keys. Stuff that's cold you don't touch because you care about it a lot. Stuff that's hot is available online, simple to use, but generally low value. Validator keys are both high value and need to be online all the time. So the more solutions we can bring around keeping those things as well protected as possible, it's important technically, it's important economically for all of the individual holders, and also for the Ethereum 2 network, because once you start seeing large numbers of people getting slashed, a lot of the concerns around not the safety of staking, but the safety of you staking rather than in general it happening, that becomes a concern. And again, you don't want to lose all of the individuals who are staking. It's very important, again, to try and keep as much of this decentralization as possible. If everyone decides the only way that they can stake is if they go and give all their money to Binance, then we've lost Ethereum too. So we cannot do that, and it's very important that we keep building these newer solutions, keep increasing the gold standard of key security.
One of the things I want to clarify, you're describing specifically the Attestant architecture. For people who are still learning about how validator signing works and how attestations work, Jim is using a custom designed solution to have remote signers and to have a race between multiple signers. For everyone using stock software, like the stock validator, if you run the validator key on more than one machine, it will result in a slashing, unless you customize that so that there's slasher protection. So basically, if you run 2 servers with the same validator keys, you will definitely be slashed, unless you have a solution like Jim has developed with failover and redundancy. So just to make that clear to everyone.
Absolutely true. That said, the software is all available. So the remote signing wallet runs inside Prism. So Prism at the moment you can run with the remote key manager. The remote signing software is it's all available online. So yeah, although it is shall we say, an advanced configuration, there's certainly nothing stopping anyone from running exactly that configuration tomorrow if they so desire.
To use, because maybe I have a misunderstanding here, with existing, say Prismatic, with existing Prismatic, you could configure 2 remote signers to, so you're running the validator key on 2 machines, 2 remote signers against 1 instance of the beacon chain, and that's not a risk of being slashed with this configuration?
So if you use that, there is something called the remote key manager. So Prism has the idea of key managers. So
I might have just missed that entirely.
Okay, yeah. So a key manager is basically a way of defining where keys have held and how they sign things. The remote key manager in Prism will talk to a remote signer. The remote signer that we have built is called WalletD, and that has slashing protection built into it. So what can happen there is you can run a Prism node with that particular key manager, point it at your own instance of wallet D, and it will use the keys on the wallet D rather than the keys on the local box. Because the slashing protection is in place, you can run multiple beacon nodes and validators using the same keys as long as you are using the remote signer. So again, the thing with the remote signer is none of the keys, the private keys, are present on the validator on the beacon node. They are only available on the remote signer. So if you kind of want to think about it in general, again, you have to ensure and continue to ensure the validator's private keys are only available in one place. So in this case, they're available on the remote signer, and you can run as many validators against it as you like because the private keys still reside in only one location on the remote signer. As a result of that, they can easily protect because they can spot when an attestation might be slashing and they can deny it.
Okay, I think where I got hung up, and I don't know if anyone else was missing the same thing. You're running the validator service, but that machine doesn't necessarily hold the validator keys.
Yeah.
And so I was linking the validator service and the validator keys on the same machine, but these are separate and distinct. You're reinforcing that you can only hold the validator keys on one machine, and that's
yes.
Great.
And as we say, this is the thing. It's there are actually lots of different architectures that can be put in place. And again, there's a bunch of benefits. There's a bunch of drawbacks for doing this, not least running multiple machines, having to secure more machines. So again, different configurations will suit for different people. One of the other things that we as a community would love to do, I think, is to have more sample configurations to be able to say, look, if there's been a lot of talk, how can we fit a validator on a Raspberry Pi? Now there's been a lot of work done on that, and actually now there's some great documentation out there. People are very clear about what they can and can't do, what their configuration is. Make sure you have an SSD of this variety. Don't just plug into that port. So there's a lot of things out there where people have started to explain and provide that level of information, which is fantastic. As a community, we probably need to build out a lot more of those to cover more different scenarios. So the more of those that come down the line, the easier it's going to be for people to say, okay, well, I'm going to look for one that fits my requirement, and that will help them. And as we said, if that's going to be remote signers or distributed keys or whatever it may be, that's great. But again, we as a community, we do have to start building more and more of those out over the next couple of months, so that when we get to mainnet launch, people can quite easily come in and say, okay, this kind of fits, I have certain requirements for my architecture, this kind of fits it, I will use that. It's going to be very, very useful to be able to do that, rather than at the moment, we have a lot of documentation that shows us how to install software, vaguely talks about hardware requirements, but doesn't really come at it from a staker's question of, okay, here I am, I have, 96 Ether, what do I do? So more of that, very, very important that we can start doing that as much as possible.
Well, in all fairness, I mean, it's still alpha software. Even though it's been in development for a long time, I see so many people who feel frustrated that it's not more highly engineered, without recognizing that we're just now trying to take flight. So these things take significant time to get right.
They do, and I mean, it's going to be tricky because we are doing the traditional engineering run of, it works for us, let's move to the next stage. There haven't been nice UIs built. There haven't been that focus on operational deployment, security, maintenance. All of these things haven't been there. Now, some of it you can argue is not part of the client team's remit, which is fair enough, but it needs to be part of someone's remit, because as we said, if as soon as we get to the point where there's real money involved, if someone puts a stake out there and it goes missing, or they don't realize they need to be having their validator on immediately, and they go away for a weekend and lose money, it's real money at that stage, and it's going to matter to people very, very much. So absolutely, it's very, very important that although we haven't done it yet, and again, it's been a moving target, so fair enough, we do need to start focusing on that pretty soon.
But it's so funny because I know, I'm guessing a 0.5% of people will click through the prompts as quickly as they can and submit their 32 Ether deposit without having any idea what's going on or what their responsibilities become. Like they'll just want to get it in. So I'm so certain those people exist.
It's great, you know, if they want to throw $6,000-7,000 around like that, okay, you know, but yeah, but equally, you're right though. But we need to not have pages of warnings saying, make sure you do this, don't do that, make sure you do this. Instead, we need to have automated systems that will actually check it beforehand. So the thing, you know, we need to have, you know, if you will, fewer words and more actions. So yeah, I mean that, and again, that is something that is certainly being worked on in a number of places and will continue to be worked on, no doubt. It's definitely something that the more we can do, the better.
Yeah. So we're about to wrap up. I have 2 programming notes. If people have questions for you about Attestant or what are the things you're interested in answering questions about, and if there are questions you're not interested in answering, what are the resources people should? I know this, like people ask me questions and I'm like, you know, I don't feel like answering that. Go read. So what are the questions you're interested in answering, and what are the resources that you would suggest for people who might find their own answers?
So I am happy to field any questions. Obviously, you know, I might point people at documents as a result or similar, but I'm always happy to field questions. It is a big space. It's not a very well indexed space. It can be very hard to kind of find the information you need. So we're always happy to get involved. On our website, you can get links to our Discord, our Telegram. I'm on Twitter. I mean, you know, you can find us pretty easily. So that shouldn't be a problem. In terms of resources, it depends what level you're going in at, but certainly if I had to pick a single resource that is worth tracking, it's probably Ben Edgington's Week in Ethereum 2 news, which is it's a newsletter. It shows up on Reddit. You know, it shows up on all the Discords. It's great. It summarizes everything that's going on. It's got great information in there. Ben does a great job of summarizing and also humanizing an awful lot of the information out there. So there's some great stuff there. Certainly that would be a fantastic jumping off point for anyone that wants to know, not necessarily from scratch what's going on, but how they can know what's happening this week, what's happening next week, what are the timelines, what's changed, what's moving around, what new exciting things are coming down the pike, all of those type of things. Very, very useful. That would be my and is my go-to resource for keeping track of what's going on in the world of Ethereum too.
Yeah. All right. Jim, thank you so much for your time.